Thanks for stopping by to check out yet another episode of Vintage Audio Review. In this episode, I'm going to talk about the iconic Sansui 9090 AM/FM stereo receiver. But before I got into that, I just wanted to thank everybody for subscribing to this channel as well as for commenting on videos when you do. The comments have been great and they make the interaction on YouTube much more fun. Also, on this review, I'm doing something a little bit different with the data where I am actually acquiring the data and talking at the same time as I am acquiring it. I don't know that you'll notice that much difference, but it helps speeds up the process of making videos. I doubt I will ever do more than one video a week. They do take a fair amount of time, but it generally is a labor of love. With that being said, let's get into the Sansui 9090. Now this was made by Sansui in the middle of what's called the stereo wars, and this particular model was made between 1975 and 1977. And it sold for about $750, which would be $4,150 today. I did check the going prices for a 9090 on eBay, and the cheap ones start at about $1,500, at least that's the auction price, and they go on up from there. I have seen some as high as $4,000 that have been refurbished. This particular unit belongs to my good buddy Ian, episode number 5. It has had some service done to the preamp board, but it's pretty much original. And according to the resident Sansui expert here in Tucson, his name is Eldon, who looked at this prior to me getting it, he said that it was designed to be sent to the United States rather than an international model due to the fact that the transformer switching was missing on this. There's just a plate in the back, which he said is very rare. He did go over this particular unit and replace some thyristors on the preamp board that are known to cause a problem, as well as a few resistors here and there, but he did not replace any capacitors from what I can tell. He does a really thorough job with his refurbishment of the 9090 and knows all the tricks and such involved with restoring them. The capacitors were not replaced, as I said, on this unit, and you will see that in some of the data coming up. The 9090 was rated at 110 watts per channel into 8 ohms at 0.2% THD, and we'll see how it does a little bit later on. There are a plethora of videos on the 9090 from what I saw on YouTube, and so I'm just going to highlight a few of the things I thought were rather interesting. The first thing I like about the 9090 is that when you power it on, the little protector light comes on and flashes, and then it goes green and flips the speaker protect relay on when all is well. Right now we are on the auxiliary mode. Here's our mode switch. I'm going to switch it over to the tuner. And so you can see the pretty display, the nice blue, and then we have our 2 power meters here. The lamps in here have been replaced with LEDs, which is kind of nice, so they should never go bad. We do have the ability to run 3 sets of speakers. You can run 2 of them at once. You can run either A or A plus B or A plus C if you want. We also have 2 headphone jacks, which is kind of odd because they don't have individual controls, but there are 2 of them there. And then you have a plethora of tone controls. Well, maybe not a plethora. If you're a JVC person, you'd have a whole equalizer there. But we have a bass, mid, and treble, and we have 2 turnover points for the bass, and we have 2 turnover points for the mid-range treble. Now, when you are on the 1.5 kHz turnover point, I believe the treble did not seem to have any effect, just the mid-range makes some sense. And when you are over here at the 3 kilohertz turnover point, both the mid-range and the treble do affect what you are listening to. It has a couple filters, low and high filters, a 20 dB muting switch, and it does have a microphone input as well and a volume control for it, and then it has some controls for the FM. One of the things that I do think it's lacking would be another auxiliary input. It does have 2 tape monitor circuits. but I think one more auxiliary input would have been nice on this. It does have separate pre-out main-in jacks on the back. So it does have an adapter for Dolby noise reduction, which would have been built into the 9090 DB. More on that in a minute. And it could be adapted for quad use, apparently. The 9090 DB had the Dolby noise reduction calibration system built in it, and I believe that is very problematic should that break, which supposedly they do a lot according to Eldon. So most people, if they don't have the need for the Dolby noise reduction, they would prefer to have a 9090. So that's kind of a quick tour of the 9090 in all its 70s glory. Right now I have a minus 10 dBV signal, or that's about 316 millivolts, applied to the 9090, such that we are getting about 5 watts into 8 ohms. And you can tell our gain is about 26 dB. That's pretty close. However, the THD for the left channel is 0.7% and for the right channel is 0.14%. The spec is 0.2% for THD. Also, the SNRs are both in the 70s, and the THD plus noise is varying. It's not, those are not really great numbers for the THD plus noise. Here we have the THD SNR plot at 1 kilohertz for the 9090, putting out 1 watt into 8 ohms. And the THD and SNR are doing a much better job than they did at 5 watts into 8 ohms. Here we have the frequency response of the 9090, and this is with the signal into 8 ohm loads and putting out 5 watts. I should point out that for this measurement and the measurement before, I was using the auxiliary input, and that all the tone controls are set to flat. So it doesn't look real good. I mean, it's a dB and a half up to maybe 100 hertz, and at 100 hertz it's only 0.6 of a dB or so, and then at the high end of the band you're dropping down to maybe 1.2 dB. So it does not have the most stellar frequency response, but this is all original from 1975 or so. Here we have the frequency response of the 9090 with it putting out 1 watt into 8 ohms, and there actually is a spec for that, and it should be plus or minus 1 dB from 10 hertz to 30 kilohertz. Well, we're going over a lesser span, and as you can see, we're down about the same that we were when we were only putting out 5 watts into 8 ohms. We are down maybe a dB and a half at 20 hertz and down maybe 1.2 dB at 20 kilohertz, depending on which channel you pick. The channel balance between the two is doing well. And the little spike that you see right here, that is the little 60 hertz that pops up. So right now we are looking at the THD SNR plot at 1 kilohertz, and we're at 110 watts into 8 ohms or thereabouts. And I'm going to slowly increase the power to where we get some distortion and see how much power we can get out of this 9090. So right there we're at 135 watts, 36 watts. We're at less than 0.1% THD for both channels. And the spec is 120 watts into 8 ohms, both channels driven at 0.2%. So that is actually at 1 kilohertz. So we're still doing pretty good. Right now you can see the left channel, we got some of these little sideband things going on here. And on the harmonic, so our distortion has gone up, and right now it's pretty ugly. We're still not at 0.2% for the left channel, and we're at 140 watts, and right there we're hit the 0.3%, which still isn't really that bad, even though the harmonic level looks pretty bad. And we're at about 143, 145 watts, depending on which channel. So I'm going to call it quits for this little test. So right now we have the 9090 putting out 110 watts or so into 8 ohms. And I'm going to go ahead and pull the harmonic content out just to see what it looks like. And this is the second harmonic, third harmonic. So it looks like are even harmonics. Here's second, and so the second's greater than the third. Here's the fourth, it's greater than the fifth. So we can see that the even harmonics tend to be larger than the odd harmonics. Right now we are looking at the multitone test data, and the goal is to have this noise level here down as far negative as it can go. In this case, we're only down, we'll say around 60 to maybe minus 65 dB. So it's basically about 10 bits of distortion-free range, which isn't really great, but for old amplifiers that I've looked at, it seems to be par for the course. What we are looking at here is the crosstalk, or as the Sansui 9090 spec calls it, channel separation. It's the same thing. And here we have a signal going into the left channel of the auxiliary input, which is this guy here around 0. And we are measuring how much of that left channel is going into the right channel. And you would want that to be as negative as possible. What we have is at 20 kilohertz, we've got about 40 dB of separation, and at 1 kilohertz, we're at about 65, almost 70 dB. Now, there is a spec of at least 50 dB at 1 kilohertz, so we have indeed gone beyond the spec, which is good. Here we have a plot showing the THD versus frequency at a couple different power levels, 25 watts, 50 watts, and 100 watts. And the specification was it needed to be less than 0.2%. And basically, it is just a tad over 0.2% at a few frequencies. But for the most part, I would say that it did a pretty good job of meeting its very old specification requirement. So this is a plot of the output impedance of the 9090. Basically, it is showing not more than 0.44 ohms up at 20 kilohertz, but predominantly it's less than 0.3 ohms for the left channel, even a bit better than the right channel. And in order to calculate the damping factor, you would take 8 for an 8 ohm speaker and divide it by, say, 0.3. In which case you would get a damping factor of 26. Now, if you did the 8 divided by 0.44, you get around 18. There is a spec for the 9090, and that was better than 30. So maybe the right channel would be better than 30, but the left channel typically isn't, and they both would fail that once they get higher in frequency. We are now going to check the accuracy of the 9090's power meters, and both channels are into 8 ohm loads. So we see that the right channel is reading pretty accurate at 0.1 watts or 100 milliwatts, and the left channel is not so accurate. It's maybe reading 150 milliwatts or so instead of 100 milliwatts. So let's go up to 1 watt and see what happens. So we are close to 1 watt for both channels. The right channel is pretty much dead on, and the left channel is about 50% off, so it's reading maybe 1.5 watts. So it still is off, and I should point out that this is just being done at 1 kilohertz. Next up, 10 watts. So we're pretty close to 10 watts for both channels, and it looks like both power meters are reading right at 10 watts, so that's pretty good. Now I'm going to jump up to 50 watts. So we're reading about 50 watts for the left channel and a bit over 50 for the right channel. And let's go ahead and see what the power meters are reading. It looks like the right is reading a bit under 50 and the left is reading right at 50. So it looks like the left channel is doing a little bit better job accurately displaying the power. And lastly, we'll take it up to 100 watts and see what's going on there. Okay, here we're at 100 watts, and it looks like the left channel is reading a bit less than 100 watts, and the right channel is reading even a little bit more less than 100 watts. So they're off a little bit at 100 watts. What we are looking at now is the THD SNR plot at 1 kilohertz with a 2-volt signal applied to the auxiliary input, and we are looking at a 2-volt signal at the preamp output. The THD looks pretty good for both channels at 0.0, we'll call it 0.04%. However, the SNR for the left channel at 61 dB isn't horrid, but it is 20 dB worse than the right channel. And the reason for that is this guy right here, the yellow 60 hertz hum component, is a lot worse than the right channels. If I go ahead and I turn off the right channel, so you can see there's the left channel, and the right channel is down a lot more than the left channel. So this right here could be due to poor power supply filtering on the left channel, or one of the amplifiers in the left channel needs a little bit more filtering on its bias. Here we have the frequency response with a 2-volt input to the auxiliary input, and this is measured at the preamp output, and the preamp is set for 0 dB of gain. And you can tell it looks pretty much like it did when it was measured at the power amplifier. Maybe a little bit better, actually. It's down a dB or so for the left channel at 20 hertz, and also maybe 0.8 of a dB at 20 kilohertz. So it actually looks better as just a preamp, which is kind of what you would expect. So right now I've got a 0 dBV signal going into the auxiliary input, and we're still measuring it out at the preamp output, and I wanted to flip on the loudness control to see what that does to the frequency response. And there you have kind of your classic smiley face, I guess you'd call it. It boosts the low part of the band maybe 8 dB, and the high end of the band maybe 12 dB. Right now we are looking at the frequency response of the auxiliary input, and we're actually putting out about 5 watts into 8 ohm loads. And what I am going to do is show you what happens when I put the low filter in. It takes it a few sweeps here for it to stabilize. And at 20 hertz we dropped about 15 dB. And now I'm going to turn the low filter off, and we'll see what happens when we put in the high filter. And the high filter looks like at 20 kilohertz it's down 15, 16 dB. So right now we're looking at the frequency response of the auxiliary input once again, and I want to see the effect of the 20 dB muting switch. So at 1 kilohertz we are at approximately 16 dBV. And I'll put the switch in. It takes a few sweeps for the analyzer to catch up here, and it looks like we're at about minus 4 dBV, so that is indeed a 20 dB muting switch. Here we have the THD SNR response at 1 kilohertz for the phono input with a 5 millivolt or minus 46 dBV input level, and we're putting out about 200 millivolts. Now I am measuring at the tape monitor output, tape monitor 1 output. Also, our gain is about 32 dB, our THD is really low, and our SNR is between 55 and 61, let's call it. Also, you can see the biggest fiend for that low SNR is the 60 hertz spike right here, and that is from the power supply. Here we have the frequency response of the phono stage measured at the tape monitor output with a minus 46 dBV or 5 millivolt input, and it should be plus or minus 0.5 dB according to the original specification. We are maybe 0.6 dB at the high end here, and at the low end we're down 1.5, 1.6 dB, so it's not meeting it there. We're also getting some of this 60 hertz hum from the power supply kind of affecting this little glitch here. That's what's causing that. But overall, once you get above 100 hertz, it is within that requirement of plus or minus half a dB. Here we have the channel separation or crosstalk of the phono stage with a signal applied to the left input here, and here is the bleed through that's being measured at the right channel in red, and the specification is also 50 dB down at 1 kilohertz, and we are about 70 dB down, and we're a little bit better at 20 kilohertz than we were with the auxiliary input. So here we're at about, I don't know, 48 dB down. So that is the channel to channel isolation. As you can tell from the data, this 9090 met most of its specifications from 1975 to 1977. It was off a bit on some of the frequency responses at the extreme ends of the band, but overall it did a pretty good job, at least in my opinion. Now, it is all original, except for Eldon replaced several of the resistors. There were fusible resistors in there that were replaced per Sansui's recommendation, from what I gather, and he replaced several of those and removed the output transistors, made sure they were tight. I guess they were kind of loose, and reapplied new grease to them. So other than that, it was pretty much original, and there were no replacements of the capacitors. So my guess is, from what I saw, it probably could stand having some of the power supply related capacitors replaced. For my listening test, I paired the 9090 up with a pair of Wilson Watt Series 3 Puppy 2 speakers. You can see one of them over there. I'm auditioning them, and eventually will do a review on them at some point with measurements and all. I will say this, that they're fairly efficient speakers. I believe they're close to a 4-ohm speaker, and with the 9090 putting out 5 watts into 8 ohms according to the power meter, it was pretty loud in here. It was, I was reaching 92 dB SPLs, and it sounded really good. At lower levels it sounded really good as well. I do like listening with the loudness control on, so I did most of my listening that way, and it just did a good job. The Wilsons are probably not the typical speaker that an owner of a 9090 is going to pair with. I'm thinking some Altex or JBLs or something, but they definitely work really good with the 9090, and it had plenty of power to drive them. They seem to be an efficient speaker, just from what I've noticed. Anyway, I really enjoyed listening to the combination, and the 9090 never got hot. The top here just was barely, you could barely tell it had been on, and the heat sinks in the back where the transistor cover over the heat sinks didn't get hot at all. It was maybe 90 degrees F after some listening, and it just does a really nice job. I like just the look of it. Now, when you're listening to the auxiliary input, you just have the glow of the power meters. Now, they are kind of hard to see. The power meters are small, and so you have to be closer to them to actually see the levels, but as you saw from the data, they work decently depending on what power they're trying to measure. So there is some hiss on the 9090. So what I do is I terminate either the phono input or the auxiliary input with a short or 50 ohm load, more precisely, but that's basically a short for audio frequencies. And I will listen for hum, and if you get right next to the tweeter mid-range on the speaker, you're able to hear some hum out of either the phono input or the auxiliary input. It's pretty normal for receivers and amplifiers that I test that are older. It's something that goes away once you're a few feet away, and you definitely wouldn't hear it with music, at least music that I listen to. So that was really the only little negative, and there was really no turn on thumps or turn off thumps, other than you do hear the relay, which is normal. I did measure the DC offset. That's something I'm going to try to do more often. I don't know what the spec is, but I measured 18 millivolts on the right channel and 2.2 millivolts on the left channel, for what it's worth. I believe Eldon measured it, and his measurements were a bit different than mine. So overall, I was very pleased with the way the 9090 sounded and how it looks and its functionality. Once again, I thank you for watching, and if you have not subscribed, please do so. And if you like this video, please hit the like button, and of course I'd love to hear any comments. And until next time, have a great day or night.